So this is a continuation of 12.2 on hyperbola. So we've already talked about hyperbola whose center was the origin. So now we're going to talk about the hyperbola whose center is away from the origin. And as we know from ellipses, the center we typically use as the letters H and K. So very similar to the hyperbola whose center is at the origin, we have the transverse axis parallel to the x-axis is horizontal in an equation that has this form. Now, we know that unlike ellipses, that the transverse axis, or you can think of it as kind of like the major axis, is determined by which variable comes first in the equation. Okay, so we have that x squared coming first, whereas down here we have that y squared coming first, which makes it for a vertical transverse axis. Much like ellipses, we have those formulas for the foci and the vertices. But unlike ellipses, we get those asymptotes with these hyperbola. Now, the equations of the asymptotes can be helpful in some cases. As you guys know, I typically try to use that little, dotted rectangle business to find my asymptotes instead of an equation. But there are times where this equation does come in handy, so it is useful to have. Okay, so really the only difference from this and the center at the origin, of course, is the presence of the HK business. So let's just dive right into an example. So let's find the equation of the hyperbola that has a center of 1, 4, focus of -2, 4, and a vertex at 0, 4. So here's all the information. So first I just kind of plotted those out to get a visual of what's going on. Right? So I've got my center, vertex, foci. So from that tells me a lot of really good information. It tells me that my transverse axis is horizontal or parallel to the x-axis. Are you guys familiar with that symbol for parallel? Maybe from geometry. So that's not 11. That's a symbol for parallel. So I can see those being in a line that my transverse axis is going to be horizontal. My center, of course, was given to be 1, 4. So I know H and K from that. And from these other points, I can tell A and C. Right? A comes from the vertex, C comes from the focus. So I get that distance from the center to a vertex is 1. And then that distance from the center to one of the focus, or one of the foci, is 3. So that's all pretty cool, right? We can get all that just from that information. The only other thing it seems like we need in order for the equation is B. Well, we know the relationship between A, B, and C for hyperbola. And that is that C squared is A squared plus B squared. So using that and plugging in the A and the C that we already know, we get that B squared is 8. Now, why didn't I solve it for B? Why didn't I go ahead and say, hey, B was the square root of 8? Well, because I knew that I was going to be putting it into the equation. And in the standard form of the equation is A squared and B squared. So I just didn't bother taking the square root only to go back and re-square it. So that's why I just left it like that. I didn't have to graph it. I didn't have to find the other vertex, the other focus, none of that stuff. The asymptotes, none of that. I just asked for the equation. All right. Let's go on to another one. This one's going to be a little more involved. All right, so let's find the center, the transverse axis, asymptotes, vertices, foci, and the graph of the hyperbola. This isn't in standard form yet. It's close. But you see that number over here? That's not a 1. So much like we did with ellipses, remember when we had to get them in standard form and do some completing the square, we're going to divide each one of these by 9. So in doing so, that's going to put that over 9. Putting that over 9 is going to cancel the 9 that was there. And then putting this over 9 is going to make that a 1. So now I have my standard form. I can tell a lot from this. So comparing this to your formula sheet, you can tell that this x being first means that I'm going to have a horizontal transverse axis. I can tell that the center is going to be a -4, 3. And I can already tell what my a squared and b squared is going to be. So again, I used that symbol for parallel. Then I came back later and was like, they may not know that symbol, and so I wrote it in there. So the center, I get from there. The transverse axis, I get from the x coming first, not from the 9. Don't get that confused with an ellipse. I have a squared is 9, b squared is 1. So the relationship between a, b, and c here. Don't get that confused with the ellipse formula. So I get that c is square root of 10, or about 3.16. Now the reason I wrote that as a decimal is because I know I'm going to have to graph it. So I'm going to put those in decimal forms when I graph it. So my vertices are going to come from -4 plus or minus 3, that 3 coming from a, comma 3. So -4 plus 3 is -1, -4 minus 3 is -7. And then my foci come from a similar computation, but this time with c. So instead of using root 10, I used the decimal of 3.16. So I did -4 plus 3.16, -4 minus 3.16, and that gave me this -7.16. So I've got the center, I've got the transverse axis, I've got my vertices, I've got my foci. The asymptotes are going to be plus or minus. Now, how do you know which asymptote formula to use? Well, because the transverse axis is horizontal, for horizontal transverse axes, we're going to use these equations of the asymptote. So it's going to be that plus or minus b over a, x minus h plus k. So b over a, x minus h plus k. Okay. And then lastly is my graph. So these were just carried over from the other page, just so I could have some points to connect. So I've got my center back here at -4, 3. My vertices are over here at -1, 3 and -7, 3. And then the foci, I plotted those. Remember, because this is sort of like an ellipse cut in half and flipped outward, that this is going to open toward that focus, and it's going to open toward that focus. That b value of 1 tells me from the center I'm going to go up 1 unit, down 1 unit, and then connecting the vertices with those points, I get that little rectangle. The rectangle helps me get my asymptotes. You could have graphed these asymptotes by just graphing those two equations of the asymptotes, but at least my opinion is that this way is a lot easier than trying to use slope-intercept on those two equations. So you need those asymptotes to tell you how wide or how skinny your hyperbola are. So the actual graph of the hyperbola is just this blue. Okay, all this other stuff were these imaginary lines that just kind of guided us along the way. Okie dokie. So this is going to look really familiar because we did one of these with the ellipse section. We're going to find the center, the vertices, foci, and asymptotes of the hyperbola, but first we have to get it in standard form by completing the square. These are really the worst case scenario for these types of problems, is the ones where it's not in standard form, not even close to being in standard form. So you have to do all this algebra before you could even do the hyperbola stuff. So just like before, I'm going to group my terms. So I grouped my x's, I grouped my y's, I just rearranged the terms. And then I put this constant, just kind of kicked him over to the other side. Remember to complete the square, that leading coefficient of the squared has to be a 1. That means I'm going to have to factor out a 4 from these two x terms. And then I'm going to have to factor out a -1 from the y terms. So in doing that, that's going to put a negative out here. There's my +1 for my y squared. But look, if I factor out a negative from that +6, it becomes a -6. All right. Now we're ready to complete the square. Remember, the completing the square is taking half of the middle term and then squaring it. So half of 8 is 4. 4 squared is 16. I got to balance it out. So if I add 16 over here, I got to add 64 over here. Wait, what? Why? Because of this 4. So I didn't actually add 16. I added 16, but it was being multiplied by 4. So that's really 64 to balance it out. Over here, if I take half of 6, which is 3, 3 squared is 9. But remember, this isn't a 9. This is a -9. So I got to balance it out with a -9 over here. All right, simplifying this trinomial factors into x plus 4 times x plus 4, or x plus 4 quantity squared. This trinomial factors into y minus 3, or y minus 3 quantity squared. And then to get it in standard form, I need a 1 right here. So I'm going to divide each one of these by 16. In doing that, this 4 and this 16 are going to reduce. That fraction is going to reduce to be 1/4. Right? I just didn't write that 1 right here. That's going to simplify to be 1. All right, at long last, it is in standard form. So now, from the standard form, I can see what my a squared is, what my b squared is, what my center is, right? So the center is going to be -4, 3. And once again, my x squared is my first term here, so that tells me which way my transverse axis is going to be. It's going to be horizontal. All right, so let's finish this guy up. So I just rewrote it. So we can tell from looking at this that a squared is 4, so a is 2. B squared is 16, so b is 4. Using the relationship for a, b, and c for hyperbola, we get that c is 2√5. Now I color-coded those because down here when I go to find the vertices and the foci, I wanted to show you what number I was using and why. So the center was -4, 3. Transverse axis was horizontal. My vertices are going to come from taking my center here, and because it's horizontal, the transverse axis is horizontal, I'm going to add and subtract a to my x value. So this is really 2 points, -4 plus 2 and -4 minus 2. For the foci, I'm going to do the same thing, but I'm just going to use the value of c. In this case, it was 2√5. Now, I just left it like that. I didn't bother, expanding that out. I just left it like that, and it's perfectly fine in WebAssign if you do that too. I would only write that as a decimal if I was going to graph it. All right, and lastly, the asymptotes. So because it's a horizontal transverse axis, I'm going to use the b over a slope. You know, these equations are exactly the same, just one way is b over a and one way is a over b for your slope. All right, so we're going to use the b over a. So b was 4, a is 2. So it was plus or minus b over a, and then this part was the x minus h plus k. So that being my h, that being my k. All right, now I'm just going to split these up into their two equations. All right, so because this plus or minus is a way of compressing two equations into one. So the plus one, I split over here. Now this 4 over 2, we know is just 2. So I got 2, x plus 4 plus 3. And then the minus 2. And then the rest of it, x plus 4 plus 3. All right, let's distribute that 2 and then combine our like terms. We get one of those asymptotes. Distribute the minus 2, combine the like terms, I get the other asymptote. So I just clean those asymptotes up a little bit for WebAssign. If you were doing this on a test for me, I'd be perfectly fine with you just stopping right there and just being done with it. You don't have to simplify them any further. So. Okie dokie, so that finishes our section on hyperbola.